is an object that knows how to call a method or a group of methods. A simpler way to define that is a delegate is a reference or a pointer to a function. Now, why do we need something like that? We can call methods directly. Why do we need a delegate that is responsible for calling methods for us? Well, this technique allows us to create applications that are extensible and flexible. And often this is used in designing frameworks. Let me explain this in code. Here in this project, I have a class of photo that represents a photo or an image. A photo processor, which has one method called process. It takes a path to a file, loads the photo, applies a set of filters like brightness, contrast, and resizes the photo. Let's take a look at the photo filters. For simplicity, I have just used console.write line because we don't want to get distracted with image processing algorithms here. But the point here is, imagine you're responsible for designing a framework that is used for processing photos. This code has a problem. It's not extensible. What do I mean by that? Well, look, so far we have applied 3 filters here. What if you release this framework, but another developer wants to use your framework and apply a new filter that you haven't defined? Then the problem is you have to create that filter and recompile and redeploy your code. Now imagine if every time a developer in the world needs a filter, you have to keep compiling and deploying your code. And this is not a good idea. So with delegates, we can make this framework extensible such that a developer can create their own filters without relying on you. The same problem can be solved by interfaces using some kind of polymorphism. But in this video, I'm going to show you how to use delegates to achieve this. Later, I will give you a simple guideline to choose whether to use delegates or interfaces. So before we change anything in this code, let's run the application and see what happens. So we got 3 messages on the console, applying brightness, contrast, and resizing photo. How do we use a delegate to make this extensible? First, we need to define a delegate type. So we start with public, delegate. When defining delegates, we need to define the signature of the method that this delegate will be responsible for calling. So let's say void, and I'm going to call it photo filter handler. It takes a parameter of type photo, and that's it. So this is the name of our delegate, and an instance of that delegate can hold a pointer to a function or a group of functions that have the signature. So they're void and take a parameter of type photo. Now to make this method extensible, instead of hard coding these filters here, I'm going to get rid of that and pass a delegate to this method. And call it here, passing our photo object. What this means is this code does not know what filter will be applied, and it's the responsibility of the client of this code. Whoever is using that, they will define the filters they want. Maybe a developer wants to apply only brightness and contrast. Maybe another developer wants to apply 10 other filters. It's up to them. This framework does not have to be recompiled and redeployed, which makes it extensible. Now, the client of this class is our program.cs. And imagine this is the code that you as a developer or a consumer of that framework is writing. So here, first, we have our photo processor instantiated. Now, let's create an instance of that delegate. So our delegate is photo processor. I defined it in that class, and it's called photo filter handler. So filter handler equals, I'm going to point it to a method. What method? Well, we can start with this photo filters. Let's assume that this was released with the framework. So let's say we want that delegate to point to this method first. I create an instance of photo filters. Filters equals new photo filters. Right? Now my handler, which is a delegate or a pointer to a method, is going to point to filters dot apply brightness. And in our process method, we pass this filter handler here. So now if I execute this code, let's see what happens. We get apply brightness. We can easily change this code and apply another filter. So we get the delegate here and we use the plus equal operator to add another filter or another pointer. Filters.apply contrast. Let's run the application again. Look, now we got two filters. And what is interesting is that if I need a filter that was not released with the framework, I can create my own here. Let's say I would like to create a filter for removing red eye. Static void remove red eye filter. It takes a parameter of photo. So this method should confirm with the signature we defined here for our delegate. So again, a delegate is a pointer to a method with the signature. Back in our program. So this is my custom filter. And here I'm going to type in console.writeLine, apply, remove red eye. I can go ahead here and add that to our delegate to remove red eye filter. Let's run the application. There you go. We got the new filter here. So delegates are very powerful and allows us to create applications or frameworks that are extensible and very flexible. Again, you saw that I added this new filter here, but that class, the photo processor, was absolutely unchanged. So was the photo filters that were released with the framework. Now let's get back to our program. I want to show you what happens under the hood when we create a delegate. So I'm going to put a breakpoint here with F9 and press F5 to run the application in the debug mode. Okay, let's inspect this filter handler variable. Look, it derives from multicast delegate class. So every delegate in .NET that we create with the delegate keyword is essentially a class that derives from multicast delegate. Let's expand that. So that class, multicast delegate, is derived from system.delegate. Let's expand this. This delegate class has two public properties, a method and a target. Method represents the method that the delegate is pointing to. So in this case, we set our delegate to point to apply brightness method of photo filters class. So target is the class that holds that method. Now, let's continue execution one line. So F10. Let's see what happens. Filter handler. I expand it here. Because it derives from multicast delegate, that means we can have pointers to many functions, which in this case, we have two functions or two methods, apply brightness and apply contrast. Let's take a look. So if I expand multicast delegate in the non-public members, it has a field called invocation list. Let's expand that. So it has two methods. One is apply brightness, one is apply contrast. So the difference between multicast delegate here and delegate is that multicast delegate allows us to have multiple function pointers, whereas delegate allows us to have only one function pointer. So in this case, because we are appending multiple filters, multiple function pointers to our delegate is a multicast delegate. Okay, let me stop the debugger. Okay, now you have an understanding of what delegates are and what we can do with them. Let's go back to our photo processor code here. See here we defined a custom delegate that points to a method that returns void and takes a parameter of type photo. Instead of creating our custom delegate, we could use one of the existing delegates that come in .NET Framework. In .NET, we have two delegates that are generic, and they are action and func. Let me show you how they work. System.action. So action, as you see from the icon here, is a delegate. It comes in two forms. One is non-generic and one is generic. Let's look at this one. Look, it has 16 overloads. One that takes only one parameter. Here is another one that takes 2 parameters, 3 parameters, and up to 16 parameters. So this action can point to a method that takes any of these parameters, a method that takes 1 parameter or up to 16 parameters. We have another delegate, which is func. Let's take a look at this one. The difference between func and action is func points to a method that returns a value, whereas action points to a method that returns void. So in this case, look, the first overload of func specifies out to result, and that is used to specify the return value from that method. If our method has 1 parameter and returns a value, we can use this overload. Or if our method has 2 parameters and returns value, we can use this one. So all these 16, 17, maybe 18 overloads gives you a lot of flexibility, which means you don't need to go and create your custom delegates. So let's change our application a little bit. I'm going to get rid of this photo filter handler and instead use the generic action delegate. So in the process method, we say you can pass any delegate that takes a photo as an argument and returns void. Let's run the application. We had an error here, which is saying the type name photo filter handler does not exist in the type delegates photo processor. So here, I forgot to change that. Here, instead of using the custom delegate, we use action of photo. Let's run the application. All good. So to recap, a delegate is a pointer to a function, or more accurately, it's an object that knows how to call a method or a group of methods. We use delegates to achieve flexibility and extensibility. Of course, we don't need this all the time, but if you're designing an application or a framework where extensibility or flexibility is a concern, we can use delegates for that. Alternatively, we can use interfaces. How do we decide whether we need to use an interface or a delegate to achieve flexibility? Well, part of that is personal preference, and different developers have different tastes. But the guideline in MSDN suggests to use delegates when we have some kind of eventing design pattern, or the caller doesn't need to access other properties, methods, or interfaces on the object implementing the method. In the case of the example I showed you, our filters were just one basic simple method, and there were no other properties or methods. But imagine if our photo processor needed to access other properties or methods. Obviously, a delegate wouldn't work, and we had to use an interface. Well, that's it for this video. I hope you enjoyed it, and thank you for watching.